Hi, and welcome to this video on differentiation, maths made easy. And today we're going to talk about related rates. Rates implies with respect to time. So with differentiation we write, if it's to do with volume, dv by dt, with height, dh by dt, we say radius, dr by dt, always with respect to time on the bottom. And now when we're talking about related rates, we always differentiate implicitly with respect to t, and I'll give a little example of how this is carried out. Say the area of a circle is given by pi r squared. So when we're differentiating dA by dt, we get pi is a constant, so that remains where it is. So we bring the 2 down and reduce the power by 1, so we get pi 2r, and then also, because we're going to differentiate implicitly with respect to t, we get dr by dt. So this is important when we're doing implicit differentiation. At the end we always put the dr by the dt because we're differentiating implicitly. So let's give some examples. So water flowing out of a cylinder for radius 4 meters at a rate 6 meters cubed per minute. What is the rate of decrease of h when h equals 6? So let's draw a quick diagram. A little hole in the cylinder at the bottom, full of water. This is h, and the water is coming out at a rate of 6 meters cubed per min. And also we know that the radius, so make that into a surface, and the radius from the center to the outside, that's the radius, equals 4 meters. So what formula can we use? Now we know that the volume of a cylinder is given by pi r squared, which is the area of the bottom disk, or the disk of water at the top, and we multiply that by the h. We get volume equals pi r squared times h. Now when we have r equals 4 meters, this becomes pi 16 h, and we differentiate, that becomes 16 pi, and h can be considered as having a power of 1, so we bring the 1 down, then the h becomes 1 minus 1, which is 0, so that becomes 0, and it's eliminated. And because we're differentiating with respect to t, we get dh by dt. So this becomes 16 pi dh by dt. We know that the volume flowing out is 6 meters by 6 meters cubed per minute, so dv by dt equals 6. So 6 equals 16 pi dh by dt, 6 over 16 pi, and that is the rate of decrease of h. This h equals 6 is irrelevant because the flow is the same whatever the height, because the radius of the cylinder remains the same. So in this question, an ink blot, the radius is increasing at a rate of 1.5 millimeters per second, and we have to find the rate of increase of area after 4 seconds. So if you've ever done this experiment to separate the colours of the ink, when we put the blot there, it increases in size. That's the radius, and it's increasing at a rate of 1.5 millimeters per second. So dr by dt equals 1.5 millimeters per second. After 4 seconds, this becomes, if we convert that into centimeters, that's 0.15 centimeters per second. After 4 seconds, it will be 0.6 centimeters. So let's have a look. What's the area for a circle? Pi r squared. So dA, the area, by dt equals, bring the 2 down, so that's 2 pi r dr by dt, because we're differentiating implicitly. So dA by dt is 2 pi 0.6, which we got after 4 seconds, times 0.15 centimeters squared per second. And that is the answer. In this question, a boy is flying a kite at a height of 112 meters, and the line paid out so far is 130 meters when it's 112 meters high. The kite's travelling horizontally at 6 meters per second, and what's the rate the boy's paying the string out? Let's draw a diagram. So this is 130, and that's the line. The kite is here. This is 112, the height. X we don't know. So from Pythagoras we know that L squared equals x squared plus 112 squared. So, and we know that they've told us that it's travelling horizontally, so that's dx by dt is 6. We want to find x, so using Pythagoras we get x is 66. Now when we're differentiating, because this is L squared, we get 2L dl by dt equals 2x, and we can ignore the 112 because we're purely interested in the x, because it's travelling horizontally, so it's 2x, bring the 2 down, dx by dt. 2L becomes 260, dl by dt equals 2x is 2 times 66, which is 132, and dx by dt we know is 6. So 260 dl by dt equals 792, and dl by dt 792 over 260 meters per second, which is around about 3.04, and that is the answer. This is a little bit more complicated because we're talking about a cone and the rate varies with the height. So let's draw a quick diagram. That's our cone. So if we draw a line down, this is R, that should be 90 degrees. And this whole thing was 60 degrees, so this is 30 degrees. And this is H. And the water being poured in at a rate of 2 meters cubed per minute. So the volume of a cone is 1/3 pi r squared h. Now we need to know, because we have two variables, we need to get rid of one variable, so we want to put r in terms of h. So using our trig knowledge, we get r equals h tan 30 degrees. So now we put this into the equation. So v equals 1/3 pi. 1/3 pi is a constant, and instead of r we put h tan 30 degrees squared h. Rearranging this, getting rid of the bracket, this becomes 1/3 pi h cubed tan squared 30 degrees. Tan squared 30 degrees is 1/3. So this becomes 1/3 pi. No, 1/3 times a third, 1/9 pi. And then we differentiate the h, so we get 3h squared. So bring the 3 down, 3 minus 1, 2. And then because we're differentiating implicitly dh by dt. Now so dv by dt equals 1/3 pi h squared dh by dt. Rearranging, taking the 1/3 pi h squared over to the other side, and dv by dt is 2, we get that. The h squared, because the h is 1, that is eliminated, and we get 2 over 1/3 pi equals dH by dt, which is 6 over pi meters. And that is the answer. A balloon is expanded, the radius of the balloon or the sphere is increasing by 2 centimeters per second, and we have to find the rate of increase of the surface area when r is 3 centimeters. So we have a balloon and has a radius and also the surface area of the balloon. As the radius increases, the surface area will increase. The area of a sphere is given by 4 pi r squared, that's the surface area. We know that dr by dt is 2, so the radius, that's the rate of increase of the radius, and we want to find dA by dt. So differentiating, we get dA by dt is, bring the 2 down, 4 pi, which is the constant, r, 2 minus 1 is 1, which remains as r, and then we're differentiating implicitly, so we get dr by dt. Rearranging, we have 8 pi r dr by dt. R is 3 times 8, 24 pi dr by dt, and that equals 48 pi. Again, the surface area is increasing at a rate of 2 meters squared per minute. What's the rate of volume increase when r equals 4? So again, we have a sphere or a balloon, radius r. As the balloon is, or the sphere is inflated, as r increases, the surface area increases. Now in this case we need to find out the rate of volume increase, but we're not given the radius, the rate of dr by t, how fast the radius is increasing, which makes it a little bit more complicated, but let's go and give it a shot. So volume of a sphere, given by 4/3 pi r cubed. When we're differentiating, dV by dt becomes, bring 3 down, 4/3 pi. 3 minus 1 is 2, so that becomes r squared, and because we're differentiating implicitly, we get dr by dt, which we don't know. So this becomes 64 pi dr by dt. So now we want to work out what we can use as dr by dt. So what other formula do we know? We know the formula for area, The area of a sphere is 4 pi r squared dA by dt, 8 pi r dr by dt, which is 32 pi. So dr by dt equals 2 over 32 pi. So we can put this answer for dr by dt back into this, so that becomes 64 pi dr by dt, which we said was 2 over 32. That cancels with that. That gives you a 2, gives you 1, and the answer is 4. And that is the answer.